we had word 1 equals, let's do pencil, and word 2 equals pencil, and of course just by habit I'm doing semicolons. We did word 1 dot compare to word 2. What do you think our product would be from that? Well, if we look at this, go inside Java's brain, it's taking pencil, using that as its base point, and comparing it to pencil. So is it less than, greater than, or equal to? If we go on the number line and all of these letters line up exactly the same, then what do you think our value is going to be? So the answer is going to be equals, because pencil and pencil share the same value, and if you subtract 100 minus 100, it's 0. 80 minus 80, 0. So again, it's going to be equal to, and then you're probably going to get 0. Now, last example, say we have word 1 equals gregarious, and word 2 equals, let's think of SAT vocab, sallow. And we say word 1 dot compare to word 2. What's our output going to be? So, again, go inside Java's brain. We have gregarious. That's our base point. And sallow. Now, I kind of did something different with this because gregarious has an uppercase G and sallow has a lowercase s. So, again, if we go back to what I wrote on that first page, the uppercase values are automatically less than your lowercase values. Just because, again, going back to the number line, which I feel really helps with this, we'd have an uppercase A and a lowercase z all the way on that far end. Of course, this is lots of space in between that. And before, when I was drawing my number lines, I just eliminated the uppercase A to show you, to make it a smaller one. So, again, before, I was just showing you probably this part of it. Oh, sorry, that should line up with the lowercase a and z. But really, when we look at the full, just numerically, we'd have uppercase a to lowercase z. And so, gregarious would be somewhere here. That's probably too far over. And sallow would be here. And therefore, we know that these numbers are like 100 and that's 0, which of course that's not accurate. But when we're thinking through these problems, we can just assign numbers to just have them make sense in our brain. And so therefore, sallow is closer to 100 than gregarious. Sallow is probably going to be something like 89, and gregarious would probably be something like 40. That's probably way too much. 21. And so obviously, sallow is going to be a greater value than gregarious. And gregarious is therefore less than sallow. And if you subtracted them, gregarious minus sallow, you would get a negative number. And less than will always yield a negative number. Remember that when you subtract them, you go from the first term minus your second variable, string, whatever. And this is going to produce the number that you need. So Java, in this case, would return a negative number because capital G is less than lowercase s. And of course, we can also look at numbers when we do this. But of course, a number would be like, again, let's say we have string word 1 equals 22 orange. I don't know. Just felt like doing orange. And word 2 equals chimp. And this, again, if we build upon this already established line, I would have numbers all the way up here, 0 through 9, right here, and then A there. So, of course, I can look at these little small parts, like lowercase a to lowercase z. I can also look at uppercase A to uppercase Z, or 0 to 9. And this is going to be the lowest end of our line. That's the highest. So we know that 22 orange would be somewhere here, because 2, we just look at these first values, 2 and lowercase c, which would be over here, and lowercase c is definitely greater than 2, according to this scale. Therefore, if we did word 1 dot compare to word 2, we would get a negative number, just because 22 orange is less than chimp. Again, if we subtracted 22 orange minus chimp, we'd have a number like 20 minus 80, and that would give a negative number. So I really hope that this was helpful, and hopefully now you can use the compareTo methods confidently and accurately. Thank you for watching, and please comment if you have questions.